GCSE Physics boosters, and this video is about energy resources, not different types of energy. An energy resource is something that we get energy from, perhaps something that we can generate electricity from. There's an interesting pie chart there. It's going to be quite a long video. If you want to have a good look at it, pause the video, look at this pie chart. It's very interesting for 2015, which wasn't that long ago. Now, an energy resource is a supply of energy. As I said, usually something that we can generate electricity from. Now, our country needs energy. We need to turn on the lights. We need to cook our dinner. And our government has a duty to ensure that in the future we're not going to run out of electricity, so that we don't have blackouts. A blackout is when the lights don't shine, okay? And if hospitals and factories don't get electricity, the economy will be in a bad way and we won't be very happy. So government should have a long-term strategy. Now, there's lots of different ways that we can produce electricity, and each one has got advantages and disadvantages. There are questions that we need to ask. Is it renewable or is it non-renewable? Is it reliable? How easy is it to transport and store, if relevant? What impact does it have on the environment? How much electricity can it produce, and at what cost as well? And are there any other social, political, ethical or economic considerations? There's a picture there of a young lady called Greta Thunberg. I think she's probably missed more school than anybody in your school, but she's a climate activist. They're very worried about climate change, her and a few groups like Extinction Rebellion. Now, it is very, very important that we get it under control. Okay, so anyway, let's look at each energy resource individually, and I'll talk about each one. In this video, I will discuss, and there's a list. As I said, it's going to be quite a long video. I'm not going to discuss technical aspects, as in how the electricity is actually produced. For some of them, we do that in other parts of the physics course. And people have different views about many of these resources. For example, nuclear power. And I have my views and I will express them, and you should develop your own views as well. As you grow up and become an adult, you should have views, you should have opinions about things, okay? And you might not agree with some of the things I say, and that's okay. It's called having a brain. Anyway, let's get started. So, fossil fuels. Now, fossil fuels, a fossil is like the remains of a plant or an animal that you dig up out of the ground. And that's what coal, oil and gas is. They are the remains of plants and animals that lived millions of years ago. Coal used to be vegetation. Okay, our country was covered in forests for millions of years, and all of this dead vegetation built up, and it was buried and it was squashed and it became coal. Oil and gas were tiny animals that lived in the sea, okay, called plankton, and they die and they sink to the bottom of the ocean and then get covered up, and then in sedimentary rock you find oil and gas. So big problems. Is it renewable? No, it is non-renewable. It takes millions of years to form, and when it's used up, that's it. There's no more. Pollution, and this is a big problem with fossil fuels. When you burn them, it produces carbon dioxide. And carbon dioxide is a greenhouse gas. Okay, it is believed to cause global warming, which is now seen as a very, very serious issue. Global warming is causing a lot of problems around the world. Climate change and rising sea levels. Lots of big problems with global warming. However, they are reliable. Coal-fired, oil-fired, gas-fired power stations can produce lots of electricity all of the time. They are very reliable. And at the moment, we don't all have electric cars. and lots of us have gas central heating, and until we can just use electricity, we need oil and gas. Okay, hopefully in the future we will need it less and less and less. Now, those keen to promote change are meeting a lot of resistance, that should say, from companies that make a lot of money from traditional industries. In some places like Texas, there are a lot of people making a lot of money from oil, and they're very reluctant to go solar. It's a very political issue. People have arguments against getting rid of fossil fuels. But at the end of the day, eventually we are going to have to, and the sooner the better. But electric cars are going to have to be cheaper. I can't afford an electric car. Nuclear power. Now, uranium ore is mined, dug out of the ground, and then from this uranium ore, you get a very small amount of uranium. And then from this uranium, you get a very small amount of the isotope uranium-235. But if you put all that together into fuel rods, it gets very, very hot. And that's called nuclear fission. And we'll talk about that in another unit. So basically, uranium-235 fuel rods get very, very hot, produce heat, which you can make electricity with. It is non-renewable. And supplies of uranium ore are very limited. There are a few alternatives, but they're certainly not renewable either. Okay, if only we could get nuclear fusion working, but we're not quite there yet. But basically, uranium ore will probably run out about the same time fossil fuels run out. Pollution. Okay, now there are no greenhouse gases. And a lot of people see nuclear power as the way of getting rid of our reliance on fossil fuels, okay, because it doesn't contribute to global warming. Nuclear power stations produce lots of electricity 24 hours a day. They are very reliable. They make lots of electricity. However, now several accidents have occurred, and these accidents, they may not have directly killed lots of people, but they've had a devastating effect on the area. We're talking Chernobyl, and then a few years ago, Fukushima in Japan. Okay, if you don't know about these, find a YouTube clip on them. Okay, accidents do happen. Nuclear waste is very expensive to deal with safely. And generations to come, our children's children's children are going to have to deal with the nuclear waste that we are producing now. I personally think that nuclear power is a bad idea. And as renewables, as the cost of renewables is falling rapidly, the cost of nuclear power it's actually cost more than wind or solar. Do we really need nuclear? My opinion is no. I think my biggest problem with nuclear is the fact that we're creating problems for future generations. Okay, and we are creating very, very nasty nuclear waste, some of which has to be looked after for thousands of years. Biofuels. Now, you can grow crops, especially to be used as fuel. If you grow lots and lots of corn, you can get bioethanol from it, which is basically petrol. Okay, so pollution. Now, when you burn a fuel, yes, it produces carbon dioxide, but we say that these crops are carbon neutral because when the crops grow, they take in carbon dioxide. When you burn them, they give out just as much carbon dioxide. So on the whole, they don't produce more carbon dioxide. Problems with it. The big problem is that land is needed to grow biofuels, and some very poor countries which don't have a lot of other resources grow biofuels to sell abroad because it's the only way that they can make money. It's the only way their government can make money, and that puts up the price of food in that country. So there are problems with it. There are political reasons why ethically maybe it's not a great idea, for some countries to be wasting their land. Instead of growing food for people, they're growing it for export, yes, to make biofuels with. Wind. The wind turbines turn in the wind, and there is a generator attached to it which makes electricity. And you can do it on a small scale. You could just have like one turbine, or you could have lots and lots of very, very big turbines. And there's lots of these popping up all over the place. Near where I live in Redcar, out at sea, you can see 27 big turbines. Is it renewable? Yes. We're not going to run out of wind. Does it cause pollution? Well, some people don't like the look of them. If you go out to the seaside and you see loads of wind turbines, or you go to the countryside, some people aren't very happy about that. And they reckon that they can make some noise as well. The solution to that is offshore wind. If you build them a few miles out at sea, then you can't see them, and it's actually more windy as well. It just means that you have to get the electricity back onto land. Reliability. Now, it's not windy all of the time. And if it's not windy, then you're not making electricity. And if it's very, very, very windy, then you can't make electricity because they'll fall to pieces. So you've got to lock them down. Another problem is that despite the fact that these things are very big, you would need lots and lots of very large turbines. You would need hundreds of turbines to produce the same power as one decent sized coal or nuclear power station. However, the cost of wind is falling rapidly. There are more and more companies involved in this, and the cost per kilowatt hour is falling rapidly, and it's going to make more and more of a contribution. In this country, we have lots and lots of wind. In the UK, okay, on our coastlines and in our hills and in what mountains we have, we could be making a lot more use of wind power than we do. Solar power. Now, solar power converts the energy of sunlight directly into electricity. There's no turbines, they just produce electricity. And there's other ways that you can use the energy of the sun as well to generate electricity. Renewable, yes, as long as the sun shines and it's got a few billion years to go. Pollution. Now, actually making the solar the panels and disposing of them, if you do it carefully, basically when you use solar panels, there is no pollution. They don't contribute to global warming. Reliability. Now, the sun doesn't shine all the time. And in some parts of the world, especially up north here, you know, we don't get a lot of sunshine for quite a lot of the year. However, the efficiency of solar panels has improved a great deal. So they used to be only something like 5% efficient in terms of how much energy you got out of them. But that has improved a great deal, and the cost has fallen a great deal as well. Lots and lots of people, just look around your neighborhood, and there's so many houses that have got solar panels on the roof. And they may not be producing all of the electricity that house needs, but maybe they're producing half of it. Okay, so the cost of electricity is going up. Maybe it's a good idea to get some solar panels on your roof. Hydroelectricity. So you've got a valley with a little stream in it, and what you do is you build a dam, a huge concrete dam, and then that little stream becomes a lake. And it fills up with water, but then at the bottom of the dam, you've got tubes for the water to go through, which have turbines and generators in them, and you can make electricity. The picture on the left there is called the Hoover Dam, which is near Las Vegas. Is it renewable? Yes. Pollution. Now, once they are built, then it doesn't emit greenhouse gases or anything like that. Okay. They are very reliable. A large dam can produce lots and lots of electricity 24 hours a day. Problems are that there's only certain places that you can build a dam like that, and the effects on the local environment. for example, wildlife, the animals that were living in that valley's underwater now. So the effects on the local environment can be very, very significant. Geothermal. Now, in some parts of the world, the Earth's crust is very thin, and not too far underground, the rocks are very, very hot. So what you do is you pump cold water down and hot water, and if you're lucky, steam, so you can actually make electricity, comes back. And this is called geothermal power. Renewable, yes. At a particular site, after a few years, the rocks that you are taking the heat energy from may cool down. You may have to drill a bit deeper or move the plant somewhere else nearby. But essentially, it is renewable. Pollution, it doesn't contribute to global warming. There is no pollution. Reliable, yes, you get a constant supply of electricity. The big problem is that it's very limited. There aren't many places around the world that you can do this. You know, places, think about in Iceland, where they've got geysers and things because the Earth's crust is very thin. In Iceland, great. You know, not very many other places you can do it. Tides. The tide flows in and out, and if you have a large estuary, for example, the Thames estuary, as the tide flows in and out, it can make turbines underwater turn around and produce electricity. Is it renewable? Yes. And once you've built them, there is no pollution. Is it reliable? Well, they don't produce electricity all of the time, but most of the time they do. The problem there is that there's only certain places where this is possible. If you have a large estuary, there may be some problems with shipping, like boats coming in and out may have to avoid them. It's a developing but promising technology. It's something that we could make more use of in the future. Waves. Now, waves have lots of kinetic energy, especially out at sea. Okay, and we could possibly use that to make electricity. There's loads of different designs for ways that waves can make electricity. The photograph on the left, they're called Salter's ducks. And as the waves make them bob up and down, there's generators inside that make electricity. There's lots of different designs. Is it renewable? Yes. We're not going to run out of waves. Is there any pollution? No. Is it reliable? Well, offshore, there are waves just about all of the time. So you can get electricity nearly all of the time. But again, it's a developing technology. It's very experimental at the moment. There may be some problems with shipping. To make a lot of electricity, you're going to need a lot of these things. And that means you can't put them, for example, in the English Channel. There's too many ships. This is the last slide. Blimey, we got there. Now, I'd like to talk a little bit about supply and demand. Now, we need more electricity at certain times of day, for example, tea time or first thing in the morning, or winter as opposed to summer. So the demand for electricity does not always match production, especially for the renewable resources. We talked about the problem with wind and solar. Now, if you could store this energy, then that would be very useful. That would make a difference. It would make it more reliable. A lot of people who have solar panels on their roof, they have a bank of batteries as well. And then the idea is during the day, the batteries charge up, and then at night time, you use the energy in the batteries. And this is possible actually on a large scale as well. The one in the middle, pumped storage, this is possible as well, depending on geographic considerations. What you can do when you're producing more electricity than you need, you pump water up to a higher reservoir so that when you need more electricity, you can generate electricity with it. The one on the right is very interesting. All of these mirrors focusing the sun's heat energy onto salt, sodium chloride. which melts and it stores lots and lots of heat energy, so much heat energy that during the night you can actually use it to make electricity. Wow, 20-minute video. Yes,